I think any transition from one expertise to a different industry and another expertise is always difficult. So yeah, it was really hard at first, and it was a super steep learning curve. I was very lucky at university. As part of my biology degree, I actually did program. So I used Python to program biological models in different biological scenarios. So I was lucky that I had some programming knowledge, and that helped a lot going into it. But I'd never done object-oriented, I'd never even heard of Java. So yeah, super steep learning curve. I think the thing that made it easier was I was very lucky that IBM gave me the time to learn. They gave me the time, the resources, and more importantly, the mentors and support. So I really had a community behind me trying to help me get up to speed. I think we can learn loads from nature. Nature's been evolving in this deliberate process for millennia. They've had so many more years than we have to perfect these kind of processes, and we often want to mimic the same sorts of behaviors. So think about the brain, for example. The brain is this amazingly complex form of data storage, essentially. So there's currently research going into, okay, how can we mimic the way the brain records data and information in the form of chips? So there are new chips that are being created to store data in the same way that brains are to make it more efficient. So it's not just software, it's hardware as well, and I think there's loads of different things we can learn, including what I'm talking about, which is about how to architect your applications better. So mimicking the behavior that social structures within nature already do. I think it's really important for you to write notes as you go along in regards to if you're trying to implement a certain software or you're trying to integrate two different programs together, for example. It's really important that you record the steps that you've taken, because looking back on it without any notes can be really hard to remember the small individual problems that you might have come up against. So having really detailed notes as you go along might seem tedious at the time, but really helps when you're writing up documentation for others to follow in your footsteps so they don't reach the same pitfalls. I mean, it's kind of simple. The reactive architecture is documented already in the Reactive manifesto. So it's a set of specifications that were created in about 2015, and they basically go through what it means to have a reactive system. So being elastic, being resilient, being reactive, and most importantly, being message-driven underneath all of that. So by combining these four cornerstones, you're able to create a completely reactive system. I'd say the main challenges are it's a shift in the way that you have to think about the design process of your application. You're not only thinking about the individual microservices, you're now having to think about the data structure and how you can make that more reactive. You're having to think about the way that the different services within your application communicate and making sure that's as resilient and reactive as possible. And you're having to think about the resources underlying your system. Can you make those elastic? Can you make them resilient? How do you make them more cost effective? All of these things are things that you have to consider when you're implementing a reactive architecture. When you're not trying to make your application as reactive as possible, it can be easy to cut corners. It can be easy to choose the easy way out, which doesn't necessarily make for the best user interaction with your system. So it's really important for you to think about the entire system as a whole to be able to make it truly reactive.